Right, good morning. Welcome back to let's look at 19.2. In 19.2, we would like to find out on a few more equations that is related to electricity. So let's start off. For electricity, the next thing we want to calculate is on electric power. When we want to calculate electrical power, we can use the following formula: P equals to IV. So what are the relation? P is power, I is current, which the unit is ampere, and in this case, V is the potential difference, which is as a unit of volts. Okay, so this is one formula that we can use. What is the unit of electrical power? Unit of electrical power will be watts. Okay, capital W. Make sure that this is capital W. Recall that in chapter 6, we have used the following definition for power. We can use a similar one itself to rewrite for electrical energy. So sometimes we also will use the other one where power equals to energy over time. So that's exactly the same. We rearrange it, we can calculate for electrical energy, E equals to power times time. Now, few things here we need to take note, okay? There are two ways to actually use this, which we will describe below here. One way is to use in terms of joules. The second way is to calculate in terms of kilowatts. So this is not new. We have studied this in secondary 2 also, okay? So how are we going to use this? Exactly the same formula that we use here as compared to above. So let's take a look. Uh, Energy equals to power times time. We can calculate for it in terms of joules. And if we use for joules, the power P has the units of J, joules. The unit for time will then have seconds. However, if we were to use it another way itself, the power units will be kWh. Let me write this out here. Small k, capital W, small h. Please make sure that your W is capital. Okay. And the unit for time is not seconds, it will be for hours. So there are two different ways of using it. Let's show with the example below. An electric kettle operates at 2 kilowatt if it's used for 10 minutes. Find the energy consumed in joules for part A and in B kilowatt per hour. So let's start first. We understand that 2 kilowatt, this is power and this is time. Okay, so power equals to 2 kilowatt. 2 kilowatt equals to 2000 watts. We write down the formula: power equals to energy divided by time. Power is 2000, we write it down. E is what we want to find. Time will be 10 minutes times 60 seconds, so 10 times 60. Your E will be 1.2 times 10 to the power 6 joules. As you can see, there is a lot of zero inside, so that is why this is not a suitable unit when we talk about electricity for our daily household, every household itself, your electricity bill. So let's look at kWh. Power, we'll stick it to kilowatts. Please take note, small k, capital W. Time, we will change it to hours, so it's 1 over 6 hours. We put in the formula again, write down the formula: power equals energy divided by time. Rearrange it, power let's put in and hours put in, we will get it as kWh. So you can see the units is much smaller, much more manageable. Okay, so this is how we use the two units for power. Once we have the energy, we want to calculate the cost. Okay, we need to calculate the cost. How do we calculate cost? We can use the following formula: total cost equals to electrical energy. This electrical energy is kWh, is the one that we calculated here. Okay, and the unit cost itself. Sometimes unit cost can be in cents, sometimes it can be in dollars. So you got to be very careful in what is the units that they have. Let's take for example 1. An electric kettle has a power rating of 2 kilowatts. All right, so this is the power. This is the time. Calculate the amount of electrical energy used. So want to calculate electrical energy first. First step, always write down as E equals to PT. This is why is there a difference in this? Okay, so let me explain. I'll always like to differentiate between the formula power times time. Now we got to be very careful because the power here, where the one is in kWh, we need to calculate as kilowatts, and the time here will be hours. So this is a reminder to me to make sure that it's in the correct units. Okay, so I put in as 2 kilowatts, I put in the time to convert into hours, you get your answer here. Next, you want to calculate the cost. 15 cents. So this is the unit cost. So 1 kWh costs 15 cents. If 1 kWh that I have here, 1 is 15 cents, how much does it cost? So in this case, it would be either 15 cents or $0.15. So you'll be very careful the unit. Sometimes they'll specify for you. Okay. All right. Otherwise, we will stop here for the calculation of the equations. Oh yes, before we end off itself, just be mindful that there are quite a number of equations. So if you need to, always write them all down so that you can remember. Okay, so let's start off. Current equals to Q divided by T. EMF is equals to W over Q. Potential difference equals to W over Q. R is equals to V over I. R is equals to resistivity, length divided by area. Then we also have for your series. Your series, one other special one is your R total. For parallel circuit, 1 divided by R1 plus 1 divided by R2. What other formulas do we have? Then today you also have learned for P equals to IV. And yep, so that's all. Okay, thank you very much.